Today I am doing a demonstration for exoenzymes and for MVIC. We're going to do exoenzymes first. So the first thing to do is to label your plates and your tubes. So we have a starch plate here for the amylase exoenzyme test. We're going to inoculate this media with 3 microorganisms. So we're going to divide the plate into 3 sectors. One which will label BS for Bacillus subtilis, one will label EC for Escherichia coli, and one will label SE for Staphylococcus epidermidis. We'll do the same thing on our milk agar plate. The milk agar plate tests for the production of caseinase, a enzyme that breaks down the protein casein in milk. That protein is responsible for making the milk appear white. So you can see this casein plate has white color to it as a result of that casein enzyme casein protein being present. So we'll label these sectors the same as we did our starch plate. And we're also going to test for gelatinase production. We do this we test for gelatinase production in a tube of nutrient gelatin. We're only going to test 2 microorganisms, Bacillus subtilis in one tube, and Escherichia coli in the other tube. So we're going to set up our Bunsen burner and inoculate these plates, and then we will put them in 37 degrees Celsius for incubation for 48 hours. So using aseptic technique, we're going to inoculate each of these sectors with our inoculating loop. Of course, you sterilize the loop, let it cool down. Even though we're not working in a physical lab space anymore, still want to be familiar with the aseptic techniques that you have learned so far. So we're going to withdraw some Bacillus subtilis on our inoculating loop and inoculate the sector labeled BS on our milk plate. A little more organism on the loop to inoculate our starch plate. Flame the loop. Obtain a second organism. In this case, Staphylococcus. Make sure your loop cools off. Obtain some of the organism. Inoculate the sector that's labeled for the organism. And we'll do that for our third organism, Escherichia. Milk plate is complete. Starch plate is complete. Now for our nutrient gelatin. Because this is a solid medium, we use a plastic applicator stick to stab the medium with the organism so that the organism gets down into the medium and can grow. So for this one, we're using Bacillus subtilis. We'll obtain some of the organism on the end of the inoculating needle. And we will stab into the nutrient gelatin medium. Leave the lid lightly capped. Because you can't sterilize these plastic loops, or inoculating needles, you just use a different one for a different organism. Organism being E. coli. And again, stab straight down into the medium, about 2/3 of the way down, and then you lightly cap the tubes because they are going to need an aerobic environment in order to grow and produce that exoenzyme.